Thank you everyone for participating in the survey. It's been really fun to read your answers and to test your knowledge on AI, and I hope that you also found this to be useful. All right. So moving on to the next agenda item on the agenda today is really a presentation that is going to give us, again, that breakdown of what AI is and what it is not. And here to do that, it is my pleasure to introduce Matthew Smith and Gillian Dowie, both senior program specialists in the education and science departments at IDRC. They will be sharing their knowledge on AI with us. So over to you both.
Thanks, Andy. Let me see if I can share my screen here. Okay, hopefully that is okay and everyone can see it. So it's a pleasure to be here and to be able to talk about this. And thanks, Andy. And so Gillian and I are going to provide that sort of introductory AI 101. I should say, and it's probably best for those that don't really have any knowledge. It's pretty difficult to be comprehensive on AI, which is quite a large topic in about the 15 minutes or so that I have to talk about it. The way we're going to break it up is I'm going to give an overview of sort of the basics of AI, and then Gillian's going to go on, give some examples and talk about the concept of responsible AI. What I'm going to focus on is really what I think are the most important things for you to understand, the useful things for you to understand about AI, and maybe clear up some terminology. And maybe in doing so, I noticed a person said, make it less scary. Maybe sometimes familiarity reduces the level of fear, and I think that's the case actually with AI. I also should note that all of the graphics that you're going to see were actually created by something called DALL-E 3, which is a generative AI tool created by OpenAI. So I didn't make these. Okay, so just to kick it off, what is AI? There's lots of different definitions. The crux of all these definitions is that AI is really a field of study where people are trying to emulate human intelligence. So human intelligence. Yep.
Sorry, if you have shared your screen, we can't see it.
Oh, okay. Let me try again. You're right. I just totally skipped that part. My apologies. Okay. Are you seeing it now?
Yep. Perfect.
Yeah. Okay. What if I do? Can you still see it, or do you see the presentation stuff? What do you see?
Now we see your notes as well. And the
okay. All right. Awesome. Okay.
Would you be able to, sorry, Matt, to maybe zoom in so we can see a bit? It's a bit smaller on the screen here.
Oh, really? Okay. This is very awkward because it's very huge on my screen. Let me just try one more time. How about now? Is it still small?
I think it's better. Yeah.
That's good.
All right. Well, my apologies. Anyway, I'll try to get back into it. I don't want to use up too much time because there's lots of interesting examples to get into. But so I talked about this. What the crux of AI is really about emulating human intelligence, and that comes in many forms, and doing it with computers or information technology. So you can think of playing games. So you've seen AI that plays chess, for example, or something called natural language processing, which is really all about language being, of course, it's a really critical human skill, being able to communicate. So all things relating to language and communication. Vision recognition, something that people do very easily that turned out to be very difficult for computers, is recognizing objects in the world. Reasoning, logic, and motion, which is robotics. So these are all different types of intelligence that are trying to be emulated on computers. Now, before I jump into a little bit more detail about kind of specifics of AI, I think it's always, these kind of questions always come up. So it's important to, I think, talk about this briefly. This might touch on the scary bit as well. And this also provides some context. And that is sort of two major categories of AI, and general AI and narrow AI. So general AI is what you think about when you think about AI in movies. This is the artificial general intelligence. This is the explicit goal of OpenAI, is to create artificial general intelligence. This is an AI that can learn to do things, and it can adapt and generalize that learning to other tasks. And underlying this is an ability to understand and to reason. Now, I should note, this is theoretical. This doesn't exist. There's huge debates about when this is going to exist, but this is not where we are right now in the state of AI. Where we really are is what's called narrow AI, or sometimes less flattering, in a less flattering way, weak AI. And this is AI that is highly specialized. So it's trained on a very specific task. So for example, playing Go. You can train an algorithm to play Go, and it can be excellent at playing Go, better than the best human players. But that same model cannot then go on and play chess or answer a question or do other things. So it sort of breaks at the edges. So it's very, very specific, which is why they give it the term narrow AI. And this was the two major paradigms or categories of AI up until about 5 or 6 years ago, when something called foundation models burst onto the scene. And really what these foundation models have done is sort of broken down the dichotomy between the narrow AI, which is very specific tasks, and this idea of general artificial intelligence, which can generalize to many tasks, because you have these foundational models, right? And these are models that are trained on large amounts, they're pre-trained on large amounts of unstructured data, and it learns the patterns in that data. And then it can generalize from those patterns, which means you can take it and you can fine tune it and adapt it to do new sets of skills that it weren't originally trained for. And so these are what is now known as, you more commonly hear of as generative AI. And it's also what has spawned a lot of the talk about, are we actually approaching this artificial general intelligence? I personally think it lacks understanding and reasoning, so we're definitely not there yet. Although I should say that Geoffrey Hinton was one of the names in the introductory quiz. This is, and Jan LeCun, he's also a person that helped invent some of the models that underlie AI today. And they're having a debate on X Twitter just this last weekend on the extent to which they think these models actually understand. So it's an open question, although I personally fall on the side of not thinking that they understand. Okay, so that's just a little bit of quick background. I think one of the things I think it's important to understand about AI is that it is a general purpose technology. And what do I mean by that? This is actually one of the things that I think makes it such an important and interesting technology, is that it takes a general approach, its approach to learning to do things that make it applicable across many different domains of life. And so one way I like to think about it, I find it helpful, is to think about AI as prediction machines, right? So they make predictions based on large amounts of data, which is the past. So based on past, what is going to happen, or make a prediction about the future. So you can imagine every day our lives are filled with predictions that we don't even know that we're making, right? So you're driving to the store, you're making predictions about what other cars and other drivers are going to be doing about maybe what's the best way to get to the store. A doctor is making a prediction as to what the correct diagnosis is, and Netflix is predicting what you want to watch next, for example. So these AI tools are really predicting, and prediction is a fundamental element of our lives across every sector. And so it's for that reason, and it's the general approach it takes to learning that allows it to be applied in so many different domains, which is what makes it quite powerful. The other thing to maybe retain out of this is that AI is a collection of tools. It's not monolithic. There's not one type of AI. There's many types of AI. And they all sort of perform and do things a little bit differently. Today, I'm going to talk about two: supervised learning and generative AI, because those are the two that are sort of making the biggest splash right now, and that are applied the most, and I think are the most important to understand at this moment in time. Okay, supervised learning. Supervised learning is, I think, probably the most intuitive of the types of AI, in that it's just a more sophisticated way of doing something that you have probably already seen or tried to do. This is where you take an input and it predicts a particular output. So, for example, actually in the examples with the email filter, right? So you give it an email and it tells you whether that email is spam or not. Or you give it a restaurant review and it tells you whether that review is positive or negative, something called sentiment analysis. Or you give it a plant image and it tells you whether or not that plant has a particular disease, so disease diagnosis. So how does it do this? How does it learn to do this? It's pretty straightforward, actually, at a high level at least. But the first and maybe most important step is actually collecting what's called labeled data. So in his picture, for example, if you wanted to train something on recognizing images, you'd have a whole bunch of images, and all the images need to be labeled. So if you have a lion, you need to have a label of the lion saying, okay, in this picture is a lion, or in this picture is a car. You would then take that data, which is that input and output data. The input data are the pictures, and the correct output is what the label is, right? And you train the model, right? You train a model, and this is just a sort of a simplified something called a neural network. It's also the kind of like deep learning networks kind of look like this, but they're big, where you put in the input. So you put in a picture, a numeric form of the picture, and then the model itself gives you an output, right? It says, okay, we think this is I don't know, it says it's a cow, but actually it's a lion. And then you tell it, look, actually this is a lion because you have the label, and it kind of goes back and it tweaks the parameters, tweaks what the weights along the way, such that the next time you feed that lion picture in, it's more likely to have a correct output. And you do this millions and millions of times, and eventually what it's doing is you are fine-tuning that, you're training the algorithm. It's like training a function to fit a very complex set of data. It's much like a very snazzy linear regression where you've got your x and y, and you're trying to, for every x, you're trying to fit the function for the y. That's all you're doing, but this is with, you know, in with a million variables, right? So very complex statistical sort of analysis. And once you've got the model trained, it gives you the right answers. You know, it's accurate enough. Then you can run the model, and this actually can be quite lightweight. And you provide the input, and it'll give you the output prediction. So that's supervised learning, and that's the bulk of the types of applications that you see out there today. The examples that were given in the quiz, for example, are, I think, all supervised learning. Now, of course, the reason why everyone's super interested in AI recently is because of the emergence of generative AI based on those foundation models that I mentioned earlier. And generative AI is AI that generates. It doesn't give you a prediction in the same way you've got input, it gives you an output. You give it an input, and it creates something from it. Right? So there's not a correct answer, but rather it's generating text, or it's generating audio or code or images based on some sort of input. And this can be very useful, and I'm sure many of you have played with it, like ChatGPT, where it can help you write an email or summarize information or brainstorm or those kind of things. So I'm not going to get into the detail of this, but there was a breakthrough at around 2017, actually, researchers from Google and Toronto that came up with this new architecture called the transformer that allowed these, and this is for language models, that allowed language models to be trained on massive amounts of data and allowed the model to find the patterns in the data, right? Which is the key here, and it allowed it to figure it out itself, right? And when we say massive amounts of data, it's conceptually tough to get your head around. In 2021, when OpenAI trained GPT-3, I've seen this estimated to be 45 terabytes of data, which is, I guess, equivalent around 45 million books, for example. GPT-4, we don't know how much it was trained on, but the presumption is quite a bit more. So one of the interesting things about these models that they found out, and they didn't think about this way for a while in AI, but the theory kind of was, okay, could you get better performance with more and more data? And it turned out that kind of was true. And so these models just kept growing and growing. But how do these models work, right? What are they doing at a fundamental level? And interestingly, what enables them to be so like the large language models, to be so convincing in their output, right? What it's doing at a fundamental level is very, very simple conceptually. All it is doing, and this is probably the most important thing to understand about LLMs, is that they're predicting, to generate the next word, they're predicting what the next word will be. They're predicting what the next word will be based on the sequence of tokens or words that have come before, right? And it keeps doing that. It keeps predicting what the next word will be until it predicts an end token, right? And then it's done. And fundamentally, that's how it works. So if the sequence of words are "the sky is," then the model will produce a prediction, which come up and in front of you. You'll see there's actually many different words, which it could be blue, clear, usually the blue being the most likely, and maybe it predicts blue, and maybe it predicts another one depending upon the sort of level of creativity with which you have set it. Right? It could pick others. So this is very interesting. So if you could feed it, for example, I want a poem in the style of Shakespeare about a dog, right? And within the model, it's learned patterns of connections between words, right? So somewhere it's got Shakespeare, and Shakespeare's connected with other words. It's figured out some of those patterns. It's got patterns around dogs, and it's got patterns around poems. And those areas are sort of lit up. They're activated, right? And so when they all feed into making this prediction, right, which allows it to be quite creative and novel in that it's now combining these areas in ways and predicting what a potential next word would be given the input that comes before that, which is really great if you want to be creative. There are, of course, limitations to these models. And actually, there was a whole bunch of other limitations I was going to talk about, but I didn't want to talk too long. But this one is probably this is the most important one to understand. And I'm sure everyone's heard people talk about it, is hallucinations. Now, what's important to understand is that as it's going, well, you can think about large language models as sort of models that are trained, they're sort of in the clouds, in the sense that it's in a cloud of language, right? And that's all it is. It's just language words connected to other words, right? And it's learned these patterns in the language, but there is no connection between those words and reality, right? In the same way that supervised learning, you're giving it an input, you're saying, here is what it is. There's none of that. It learns the patterns on its own, and it's learning the patterns just within language itself. So there's no not only an obligation, but it's trained to just predict the next word. What is the probability of the next word showing up? There's no, is it being trained to be correct, right? It's not trying to be truthful. It's trying to produce language that is the most plausible, right? And so you can see here, lots of different potential words can come up, and it doesn't know what it's going to say, right? All it knows is what the next word is that it's going to predict, and then it keeps going. So in a way, it's sort of it's generating, it's inventing its answer as it goes, and it's pulling from all these different places that are where it has connections with the current set of words that's within it. So in that sense, like I said, it's very great. It's great if you want to be creative because it can build up novel stuff. But if your interest is in accuracy, then you might have a problem, because that is not what it's trained to do. And in fact, the way that it works probabilistically, it makes it being very accurate very difficult. Of course, there is a lot of people working on that question. But actually, if you ask me, this is a fundamental feature. It's sort of a feature and a bug, right? It's the feature of these large language models that they are probabilistic and can produce creative stuff, but the bug meaning that it then, quote unquote, will hallucinate. And I don't think that's going to change without fundamental changes to the actual architecture of these models themselves. So this is a problem that will continue at least until they've figured out a different approach. Okay, hopefully I'm not going too fast. I'm just going to summarize. So AI is a collection of tools that try to predict, and those predictions are based on lots and lots of data. The more data you have, typically, the better it can do in those predictions. And this is what makes it a general purpose technology, right? Because the predictions are something that apply to many domains of life. Supervised learning takes in labeled data sets. It learns a function from that data, and then can predict very accurately, but they can only do one specific thing that they're trained on. Generative AI can do different things like create and generate and generalize a little bit. And large language models do it by trying to predict the next word, but then they'll hallucinate, which can be a good thing if you want to be creative, but that is a challenge if you're looking for truth. And I'm going to stop it there. Of course, this is just a high-level overview. Happy to answer questions, but I'm going to turn it over to my colleague Gillian now, who can go into some more detail on examples.
Thanks. Can you go to the next slide, Matt? Okay. So now what I'm going to do is give a few, concrete examples of AI applications used mainly in the context of international development to give a sense of the potential of the technology and the kinds of tools that are emerging. These tools are, of course, surrounded by many complexities and risks, and they're also why there's so much potential for AI in development, and at the same time, why it's important to really understand how they work and the kinds of risks that they pose, both the tools themselves, maybe by replicating biases or giving inaccurate information, or at a larger scale by, for example, any sort of deepening inequality as a result of existing access and infrastructure gaps. I'll start with a couple of examples that use generative AI or the kind of ChatGPT technology that we're just talking a bit more about. The first example is in education, and it's a team at Robots Mali that is it's a research institution, a kind of a tech interfacing institution in Mali. So literacy in Mali is extremely low, and a large part of the reason why is that education is provided in French, which is not the language that people use day to day or are really exposed to from a young age. The education system is trying to address that by providing education in Bambara, a commonly used local language, but they don't have the materials to use because it's historically not been the language of education. In response, the team asked ChatGPT to create 60 books for different learning levels in French, because ChatGPT right now doesn't know Bambara or the context. And then they had education experts come in and review the books for context-specific references, like replacing donuts with a treat the kids would be more familiar with. Before this, though, the Robots Mali team had already been creating a language translation data set for Bambara. So they were able to use that data set to translate the books using their own tool, and then again have experts review the books for quality, appropriateness, and so on. The team did kind of a quick assessment of the relative value of the approach based on an earlier grant of something like I think it was $1 million, which allowed them to create 20 books in 1.5 years. And this way, they created 60 books in 3 months with, I believe it was about $100,000. But of course, already had been working on the language data set, so that might not be factored into that total cost. But regardless, they estimated that it was something like 50 times cheaper in terms of cost and time. And these books are now ready for use. But very importantly, this worked because of their translation tool that they already had, and because the involvement of human experts and educators along the way. And the second one here is in the health space, but it's out of the US. The National Eating Disorder Association had a long-running helpline that provided support to people struggling with eating disorders. With ChatGPT, they saw an opportunity to be even more responsive to even more people, so built a chatbot to provide guidance and resources based on the prompts that people would give the specific needs of the people coming to the platform. But when people started using it, they found that within just a few prompts, the chatbot started providing diet advice, tips for weight loss, like promoting calorie counting and lifestyle changes. So the association had to really quickly just shut it right down, because that kind of advice can be very harmful for people with eating disorders. What they said was that it worked at the outset, it worked really well. But in time, the AI started making up new answers beyond its original design, and it ended up being outside of their control. Could you go to the next slide, please? Thank you. Another language-based innovation that IDRC is actually supporting is a tool developed by researchers in an Ethiopian university to create a translation prototype in low-resource languages like Amharic, Ge'ez, and Hawaiian, similar to the Mali example, but designed to pick up gender bias in these languages. There's actually quite a lot of work going on kind of along these lines, which is why I want to mention it. And it's important because I think we've all heard examples of AI, let's say AI image generators creating images of women when prompted for nurse and men when prompted for doctor or engineer, or inappropriately generating really sexualized images of women when not prompted to do that. And in languages like French or Spanish that gender their nouns more than we do in English, this also comes through in defaulting to male genders in written text about the same kind of professionals. And there are lots of ways that our language, the language we use on a day-to-day, mimics these social biases, these forms of exclusion. So these are problems when they're used at a large scale. In languages like French and Spanish, and certainly English, there's genuinely more effort to find and eradicate bias and prevent these problematic responses. But the same isn't true in many of the very many low resource languages around the world, meaning if and when they do become usable with something like ChatGPT, for example, the results are going to be lower quality and the outputs are more likely to replicate the biases that we carry. So these researchers and others are trying to create tools that can detect that and work towards rectifying it. The next example on this one is in the health space again, and using predictive or sort of narrow AI, basically not ChatGPT. Jacaranda Health is an NGO providing reproductive and maternal health support in Kenya. They've been working for several years using a prompt system that basically sends SMS messages to women to remind them of important moments or information during and after pregnancy, like appointments or vaccine requirements, et cetera. This worked really well, and they were able to demonstrate a meaningful improvement in women's health outcomes around pregnancy and post-birth. They've now effectively integrated AI into their tool and have been able to do a lot of really cool things. They can target their prompts and information better. For age, for example, they'll know when they're communicating with a pregnant teen and they can give her tailored information. But the most exciting thing, I think, is that they can answer questions and use AI to triage those questions. Sometimes it's about pointing to resources or providing more basic information. But other times women will say things like they're experiencing bleeding or they have a headache for a certain amount of time. And using questions and keywords, the AI will identify the level of priority for a direct callback from a healthcare provider, or will give information that will first be reviewed by, again, a healthcare professional. It's being integrated now into county-level government hospital systems, and they're looking to expand in terms of languages and location. They're actually now able to provide the service in Swahili after building their own large language model. So this seems like a good candidate for generative AI, but so far they're actually not planning on using the technology because right now they have a lot of human involvement to make sure the quality is high, the answers are accurate, and they know exactly why the AI is generating its answers. But with generative AI, they're not confident that their answers will remain as high quality or allow for as much sort of human vetting of the responses that it's giving. Can you go to the next slide? I don't want to take too much time, so I'm actually not going to go into these, but I'll quickly just say that quite a lot of AI tools are already being developed in the agriculture and climate spaces. For example, in crop disease detection and diagnosis, or water management, drought prediction, and in education, we're seeing platforms to improve learning, like the example here of creating sign-to-text translation apps. And these are just a few of the things that are currently out there. Can you go to the next slide? So as we've been talking, we've been kind of peppering in many of the risks, I would say, of AI, and I imagine that that's, we saw in the poll, the top of mind for many of you. Since this is just the first of a series of discussions, this is a big topic. This is just the first of a series that Cooperation Canada is going to host. I expect there to be more opportunities to get into risks and mitigation in specific areas, but I'll point to some big ones for now and discuss some of the kind of global movements happening around mitigating those risks. So again, replicating bias. This happens because data is biased and incomplete and can lead to unfair and discriminatory outcomes, which is important when AI is making decisions or allocating resources based on who is represented in data. There's also more societal bias that gets replicated. This can be like the image generator example from earlier, or AI recruiting tools filtering out women for jobs as data scientists, or an access to finance in a context where there's less historical information about women's banking and loan repayment habits. So an AI tool would rate them as higher risk for a loan and maybe deny them. There are risks associated with data privacy, the collection and use of personal data without knowledge or consent. AI is trained on massive amounts of personal data. It's being developed and used in a lot of kind of unregulated environments. So AI and data privacy strategies and regulatory frameworks are needed, are very important in this case. There's also a lack of understanding about who is responsible for AI when it does something harmful, who is actually held accountable. And those are the kind of ever-present day-to-day risks, I would say. There are, of course, other risks like the use of AI by bad actors to create and spread disinformation even more widely than is already happening, and the impact that can have on public discourse and trust in institutions, or for AI to create misinformation, just information that's not accurate, not vetted. In healthcare, something with low accuracy can lead to very real consequences. And in the development space, I guess a major question is really around who is going to benefit and who gets left behind. Using AI is maybe not a real and immediate option for many people, especially those already vulnerable because they lack access to adequate infrastructure, power, low literacy levels. So we need to be very conscious about how AI is used to prevent it from widening global and in-country inequality. And of course, there are many more risks than what I'm pointing to here. Facial recognition, there's policing and military use, surveillance, and so on. Understanding and addressing these risks are crucial for the responsible development and deployment of AI technologies. And the next slide, which is my last slide. So in the international cooperation sphere, we're working to better understand how AI can contribute to development, to achieving the SDGs, but in a way that prevents harm and negative consequences. This is why we aim to support AI development and AI policymaking that aligns with responsible AI principles. As you see here, responsible AI is human-centered, fair, equitable, inclusive, and respectful of privacy and human rights and democracy, and aims to contribute positively to the public good. If AI is developed and deployed following the principles of responsible AI, and of course benefits from clearer regulatory environments, this would help to create more confidence and trust in the tools, and that they're being used and developed to serve the public good, that people understand better what they are and how they work, and to protect against those risks associated with AI by being sort of intentional from their design. Checklists, guidelines, tools to check for bias, audits, these are all in the making to support the advancement of responsible AI. The definition on the slide comes from GPI, the Global Partnership on AI, and they're just one of many groups bringing together a wide range of actors to advance responsible AI. Other resources that I can point you to are the OECD Principles of Responsible AI, the UNESCO recommendations on the ethics of AI, which was adopted by 193 member states and shows the real demand for these guidelines. And more recently, the UN's high-level advisory board on responsible AI and the multi-stakeholder advisory board, which includes people from academia, from civil society, governments, and the private sector, who all have an important role to play in terms of AI development and deployment, infrastructure expansion, for example, and creating the ecosystem for responsible AI. So I'm going to stop here and I'm going to hand it back to Andy. Thanks.
Thank you so much, Gillian and Matthew, for this insightful presentation and for these concrete examples that you've provided on the use of AI in health, agriculture, education. I'm sure we can all learn from these examples. I'm going to go ahead and get us into the next and exciting part of this webinar, which is a panel discussion. So allow me to introduce our two panelists. We have Brian Ritchie, CEO and founder of kama.ai, who will be sharing insights into indigenous AI, perspectives and values that have informed the design of kama.ai and more. And we're also lucky to have to be joined by Micheline Ayoub, who is the executive director of the Sustainability in the Digital Age think tank and the global hub director for Future Earth. Micheline will be speaking on sustainable AI and the collaborative use of AI to solve environmental issues. Welcome to both Brian and Micheline. I'll pass it over to Brian first, since your mic is on, and we can have Micheline get ready to share her slides afterwards. Over to you, Brian.
Very good. Thank you. Can you hear me all right?
Yes, we can.
Very good. Yeah. So my company is a company called kama.ai. We were a indigenous-owned developer of a conversational intelligence, which is not unlike what we hear with ChatGPT. You ask a question, you get an answer, but it works very differently. We also happen to fall into a space that is also defined as emotion AI. We have an emotional intelligence, and Matthew mentioned something called semantic analysis, and being able to understand what are these bad words? Is this person feeling badly? There's another one in Emotion AI where it's looking at a face, maybe my face in this presentation, and saying, Brian looks like he's excited, Brian looks like he's happy, or maybe Brian looks like he's sad. Those are other forms of Emotion AI. Our form understands or does its best to understand the underlying meaning behind the words. Another thing that Matthew showed was when you look at large language models, that's the GPT type, generative type for language, they, as Matthew said, they don't really have an understanding about what you have said. They put words together and they respond to an inquiry or a prompt, and they give you a number of words. The words look like they make sense, but they have no, the machine has no understanding of what you really said and what you really care about. The other thing is, as we said, they can hallucinate as well. Our AI works very differently than that. It's actually not generative. It's actually not a large language model. Our AI is based on, it's meant to be much more like humans, in our opinion. It's based on a knowledge base, and it's guided by human values, and that's what makes us an emotion AI. And if you think about, the question, what is indigenous AI? I'm not sure if we know what indigenous AI is, but we happen to be an indigenous company that set out to build an AI that is ethical, truthful, honest, those types of things, and a form of responsible AI, as Gillian was talking about. So we're actually, I'm a big fan of something called the 7 grandfather teachings. You can look them up. There's 7 key values. Each one of those values has kind of an underlying story. But the ones that we talk about on our website are the values of courage, truth, wisdom, and respect. And these are guiding principles for us. They happen to be borrowed, as I say, from the grandfather teachings. So courage, let's talk about that a little bit. We had to be courageous in believing that we could build something that no one else was doing. Everyone else was going for large language models, or before that, deep learning. And we set out in 2014. We actually started developing in 2018, but we set out in 2014 to apply for a patent around something which was very different. It was this knowledge graph guided by human values. We thought that that could be a more understandable and a more transparent way of doing things, and a more accurate way of doing things. So we had to have the courage to build something that nobody else is actually pursuing, and nobody really thought you could do something like that. So that's good. That gave us our courage to get going and get started. We're also a huge fan of truth, as many people are, of course. And if we want responsible AI, it hopefully can be truthful AI, and ideally it's not hallucinating and spreading misinformation. Well, with our truth, then we need our system to be understandable, predictable, explainable. That's a big thing. Explainable AI. If an engineer comes in or a vendor comes in and can't tell you how this AI is going to work and how it should respond, then you're probably not going to be able to predict what might come out of it. Therefore, you might have some of these risks exposed. So in using truth as a guiding principle for us, we sought out to make something that's very explainable, understandable, and transparent. You should be able to see exactly the data that's going to come out, the response that's going to come out when we understand a particular question. I mentioned that our AI is guided by human values. What does that mean? What it means is when we hear a statement, we could hear a statement such as, "I'm lonely." Well, that's a pretty simple statement, but it has pretty far-reaching human impacts, right? If I'm lonely, maybe I lack companionship, I lack communication, I feel detached from the world. And those are the things that we understand as values, and we use our system to say, I see that issue in this knowledge base. This person, a person can be lonely. And now let's look at the values. Oh, the values are negative companionship, negative communication, and they can be rated in our system, much like you hear of labeling. We talked about labeling earlier in the presentation, but ours is a label, so maybe companionship, and a rating, a number, -4 for companionship if you're lonely. So we use that as a way of guiding and being able for the machine to truly understand, have an understanding of things. So that's one of the other things that we use to guide ourselves. Another one is wisdom. If we want to value wisdom, we value the wisdom of the people. So people actually put the information into the knowledge base, and the information comes from their experience. So we call our solution a designed experiential intelligence. It's not an artificial intelligence. It's an intelligence that has been designed to work with the experience of people, and that's what you're going to get out of it. When you ask a question about what's the best way to do this or to do that, you're going to get out of it the answers that come from the people. And the people could be the subject matter experts within the marketing department of an enterprise. It could be the ESG people, environment, social, and governance people of an enterprise that want to, tell the world about what they're doing for the planet, what they're doing for society. It's those words that come out. Now, we're not generative AI bigots. We actually use tools like that inside our system, but those tools are used only to provide a draft for a human to review. And when the human completes their review, they check a box that says, I have reviewed this information and I am responsible for it, and I authorize it for use within my organization. So that's how we use, some of the indigenous guiding principles of the 7 grandfather teachings to enable and to actually build our solution. So Gillian talked a lot about responsible AI. I want to tell you that as of last week, we were very happy to endorse Canada's Code of Conduct for the responsible development of generative AI. We're now listed on that. And yesterday we put out a press release saying that we're very happy to do this. We've always set out to build something that's transparent and understandable. We believe that to be a very firm, responsible form of AI, and we're very proud to support Canada's Code of Conduct in this area. I'd like to leave it at that. I think I'm at my time. Thank you.
Thank you so much for Brian for sharing that. Micheline Ayoub, I'll pass it over to you.
Thank you, Andy. I will try to share my screen. Oh no, it's giving me a choice of different screens.
Yes.
It's a window. Oh, here it is. And perhaps I should do this so you can see it better.
Yeah, if you don't mind zooming in or presenting, go exactly. Thank you so much.
Is that fine?
Yes,
can you see it well?
It's much better, yes.
Yeah, okay, thank you. So good morning, everyone. I'm very happy to be here, and thank you for the invitation to speak about what we are doing in AI. I just want to say first, I'm not a coder, I'm a biologist by training, and I did study in agriculture later on. I'm the Executive Director of Sustainability in the Digital Age and the Director of Future Earth, the Canada Hub. First, a couple of words about who we are. Sustainability in the Digital Age is a think tank in Montreal at Concordia University. As the name implies, we are working at the intersection of sustainability and digitization. So we work on very many issues of policy making, training, as well as research in those fields at the intersection, whereby we see how digital innovation can inform sustainability and how digital innovation can be sustainable itself. We also host Future Earth, which is a global network of people working on sustainability research and climate change research as well. Future Earth has 9 offices around the world to form the secretariat. And we are working on 27 different topics related to climate change and sustainability. Why I am here today is to tell you about the examples of how we use AI either in development or in cooperation, and in a, I would say, very ethical and responsible way. So first we have a project that is going on in Africa, in Rwanda to be precise, and we hope that we can expand it into neighboring countries as well to use that as a pilot project. This project is called Data-Driven Insights for Sustainable Agriculture, or in short, DISA. It's a collaborative project that we are doing with Planet. Planet is providing us the satellite images. Future Earth and us, of course. MILA is the Artificial Intelligence Institute of Quebec. We mentioned earlier Mr. Bengio. Dr. Bengio is the person who started MILA, and he's at the head of MILA. We are also working with the RCID, which is the Regional Research Center in Rwanda, which is they work on agriculture and soil health. Leaper Labs, it's a little startup company in Rwanda as well, coming out from the university, as well as C4 ICRAF, which is a research center working on agroforestry. So all together, what we are doing is we are gathering data through surveys from the farmers, data on where does the farm start, where does the farm end, what are they planting, the harvest, etc., and how are they working their land in a sustainable manner, working in a regenerative agricultural manner. At the same time, we're using AI to analyze satellite images of 815 farms that we have surveyed in order to, by using AI and doing this analysis of the satellite images, to be able to predict the carbon sequestration and the biodiversity that would perhaps become better while using those regenerative agricultural methods, in the aim that by using satellite images later on without necessarily knowing what's happening, one can predict how people and the population on the ground can benefit from such regenerative AI. We also hope that when we get all the results at the end of our project, that we can inform the policy makers and give them this evidence, scientific evidence, in order to help make better policies for regenerative agriculture in Rwanda. And like I said, in order to use that as a pilot project for neighboring countries to help towards sustainability in the countries that are affected by climate change. The other example I want to bring of how we are using AI is here in Canada. We are using AI in the same way, almost as we are doing in Rwanda, but in a different context. We're using it to predict how nature-based solutions are working well or not in Canada. What we are doing is we are comparing nature-based solutions that were put in activity, I would say, by indigenous populations versus those that are done by provincial or the federal government. And by using AI and satellite images, we are also trying to see the carbon sequestration and the biodiversity of those activities. And AI will help us say, because we cannot do nature-based solutions everywhere at the same time, how to prioritize those nature-based solutions based on AI. And we are doing that, of course, it's always us and Future Earth with Concordia University and the RAD network of indigenous populations that are providing us with data and providing us support and advice in how to deal with certain issues related to data and applicability of AI. And we are also being supported by Ducks Unlimited Canada, MyTax, and Microsoft in this case. We are also part of an international coalition called the Coalition for Digital Environmental Sustainability. As I mentioned at the beginning, we work on how sustainability can be helped by digital tools, but also how digital tools have to be sustainable themselves. This is what CODES is for, and CODES also works towards aligning the advancement and the innovation of digital tools towards sustainability in themselves. And in this case, we are working in collaboration with the United Nations Environment Programme, the International Science Council, the Office of the Secretary General's Envoy on Technology, as well as the Ministry of Environment and Forestry and Climate Change of Kenya, and the Agency of Environment, the German Agency of Environment, or UBA. Internally, we are also using, we have a leadership program on environmental and digital innovations, as well as AI innovations for sustainability, whereby graduate students can learn about sustainability and digital tools, and they can also get leadership skills, and they do internships with us on that topic. We are also starting a working group for CODES, the coalition in itself, about education for digital sustainable development. And last but not least, in all this, we do not forget to work also on the topics, I would say the other side of the coin of how digital tools have to be themselves sustainable and ethical. I'm not going to delve into the ethical topics here because Brian talked about them before me, and my colleagues from IDRC as well. But we also like to remind people that we need to mitigate the environmental impacts of AI. Like, where do we get the energy sources for the data centers, the water usage for cooling in certain areas where data centers abound, water does not abound, although water is supposedly the best way to cool these centers. What do we do with the electronic waste? How much carbon is produced by using those data sets or those centers, data centers. There is a tool, for instance, that was provided by one of the researchers at Mila previously, now she is at Hugging Face, Dr. Lucioni, that estimates how much carbon can be produced in the air from using those tools, as well as addressing the digital divide, of course. We have produced chapters and white papers on the topic that you can see on our website. One of them is the inclusive innovation in artificial intelligence from fragmentation to wholeness, that deals with the ethical issues and the digital divide in this topic. And with that, I want to thank you for your attention, and I'm ready for questions. Thank you. And stop sharing this way.
Thank you so much, Micheline. Thank you for this presentation and how we can, future-proof AI implementation and making sure that we have environmental compliance. In the interest of time, we're not going to move to questions. Please populate your questions in the chat, and if you can indicate as well who the question is for, that way we can direct them to the experts on that specific topic here. We have a first question. I think this is for all panelists, and the question is, just one second while I read it here for you. The first question is there anything that people can do? Sorry, that's not the right question. One second here. It's for those with familiar with AI, with the AI sector. Is there any movement to develop a process to certify AI tools and verify them against standards? Maybe I can have Matt or Gillian actually answer that question first.
Yeah, I can share some thoughts. So I mean, I think that there's definitely a lot of talk about this right now, and I probably don't have the most up-to-date information about what is actually out there. There are a lot of tools being developed, like audit tools and different guidelines about development of AI. So there's quite a lot of discussion, but in terms of actually having, a certification in a specific area, I think there's still quite a lot we need to understand about what that means in different contexts, what that means in different sectors. Like that will look really different in something like healthcare than it will in a lot of other spaces, and probably come faster ultimately in an area like healthcare. So this is out there. I think that there's quite a lot of leadership right now in the EU in terms of how they're developing. Like, it's not, they don't necessarily have a verification tool, but they have a very clear, or a fairly clear, kind of regulatory framework for what AI can and can't do and what it needs to disclose and be able to sort of justify and things like that. What I think is still lacking is probably more of that regulatory environment within which AI can be developed and within which it can kind of operate and disseminate. And so that probably needs to be better formed in the near term. But there's definitely a lot happening around discussions on at least audit tools, but certainly around certification as well. But to my knowledge, there isn't one thing that has yet come out outside of the sort of government spaces that can do this. I don't know if anybody else has heard of anything.
No, thank you. Thank you so much, Gillian. I have another question here for Brian, and this one is, how do we ensure that the first concerned or the most vulnerable are included in the development of tools of AI-based solutions? I think you've touched a bit on that, but if you would like to elaborate, that would be great.
Yeah, so very good question. Thank you. And what our goal is the AI should be accessible. So there's two parts to the development. There's the development of the foundation and the model, or if you want to call it, the overall system and how it works. And then there's the programming of that. For us, it's zero code programming. We've actually been covered by a research firm called Gartner. They're one of the leading, I guess, independent research firm for technology companies. And they did an article on something called the voice of society. And the concept was enterprises, whether they're large consumer suppliers or whatever, should stop talking or listening so much to the voice of customer or consumer. They should start thinking about the voice of society. We care about the planet. We care about sustainable materials. We care about waste. And if the enterprises who do a good job at those things, that's where the consumers are going to spend their money. And in that article, they actually wrote about us, about Kama, because Kama has an accessible technology. It can be used by people. They called it micro societies. It can be used by micro societies to deliver an authentic voice. So for us, it's our goal to build an accessible platform, a platform that can be used by lay people, subject matter experts, knowledge holders, so that those knowledge holders can actually deliver their authentic messaging, voice, instructions, traditions, wisdom, whatever that is, right? So for us, it's about building accessible AI.
Thank you so much, Brian, for that answer. I have another question, and I think we'll give it to Matthew. And this question is, the AI like GPT produce a lot of generative information fast. Do you think we will have more generated data than human data in a few years?
Yeah, well, I think this probably already happened. To be honest, like the amount of data that exists today, I can't even wrap my head around it. One thing I will mention that is maybe not part of your question, but something I didn't touch on that I think is actually a really interesting thing for the future is something called synthetic data. And this is, again, a generative AI technique where you can take data sets and then an AI will create, in the same way, like you say, paint me all the pictures I did in my presentation. Give me a dog that's flying with a blue cape, right? And it'll do that. You can take a data set, and then the synthetic data approach will actually create another data set entirely from scratch, but with the same statistical properties in theory as the first data set, which then makes, if you have a data set that is includes a lot of personal information, for example, which makes it so that you can't share that data, then suddenly now you can use that new data set because it will not contain any personal information. It will contain, it's totally recreated. Actually, there's questions about whether or not you can, the limits of that. But in essence, there's a potential for it to open up all sorts of range of data sets that weren't previously not available to, say, researchers because of privacy considerations due to that. So just the short answer is yes. I think we're already there, and certainly that's only going to increase in the near future. But mostly generative AI is, I don't know if I mean, it's creating data in the sense that it's creating novel texts or images, which then can be fed back into the system. So in that sense, it's creating its own unstructured data, but not data in the sort of traditional sense that people think of, sort of the more structured data types, if that makes sense.
Thank you so much, Matthew. There's one question from Micheline here, and the question is AI different from other digital solutions that have come before it in the development space? Maybe you can answer from your perspective, since you've shared a bit on digital solutions.
Yeah, I think digital solutions abundant. They may be very, very useful and sometimes much easier to get our hands on in certain areas of the world. Definitely, AI, the way I see it, because I've worked with it before as well, is just much more powerful. It will allow us to do certain things that the simple digital tools we may have on our phones or on computers, the regular ones that almost anyone can use. Well, ChatGPT can be used by almost anyone these days, are much more. They can give us insights that those digital tools will not necessarily give us. So I think yes, and to mimic a little bit what Matthew is doing, it's like, in short, yes, they can be very powerful and they can be very helpful. There are actually recent, I would say, white papers or reports, one from Microsoft, one from Google and the Boston Consulting Group, on the topic of how AI is used in sustainability and environmental issues. And those examples are also abundant. And they do certain things that we were not able to do before.
Thank you so much, Micheline. I think we're now headed towards the end of this webinar, and I'm going to invite the Chief Executive Officer of Cooperation Canada, Kate Higgins, to join us to provide some closing remarks. And thank you so much to all the panelists. Thank you for your participation, your insights, and also to all those who have asked questions and have been here in the chat in the meantime. Thank you. Over to you, Kate.
Thank you, Andy. Merci. Well, I definitely learned a lot over the last hour and a bit. So a huge thank you to Matthew, to Gillian, to Micheline, to Brian, and to everyone that participated in this really, really important, inspiring, stimulating conversation around the role of artificial intelligence in international cooperation and development. Thank you for doing such a great job of breaking down what AI is and what it isn't, how we can use it, how we can integrate it into our work in international cooperation contexts, the things we need to think about, the risks, the challenges. So for someone like me, who is really not deep in AI, but is trying to reflect on what this transformation means for our work, my sincere thanks. It's interesting to reflect on some of the ethical considerations, inclusivity, accessibility, representation, sustainability, many of the issues that you all raised today, and thinking about all of that in the context of harnessing the power of AI, but really ensuring we're doing it in a way that is thoughtful and is accessible and is ethical and culturally sensitive. For me, this is not just about innovation. It's really about thinking how we can use AI to empower communities, to empower our work, to address inequalities, to bridge gaps, and ultimately create a safer, fairer, and more sustainable world. Donc, au nom de Coopération Canada, je tiens à remercier le CRDE de s'associer à nous.
In our name, I would like to thank CRDC for associating with us and explaining a key aspect of the digital transformation that is happening for our eyes.
Fantastic Canadian institution that is doing incredible work around the world. It's a collaboration and a partnership that us at Cooperation Canada deeply, deeply value. So a huge thanks to all of you for being part of this first webinar. We're very excited to have a second webinar on AI and international development in the new year, and I sincerely hope that you will all join us then. Merci beaucoup. Thank you.
Thank you so much, Kate. And thanks again, everyone, for joining today, for your insight. To all of the panelists, thank you for your perspectives and the knowledge that you have shared. And again, we'll be populating a poll just to take some feedback from you here. So if Fraser, you can populate the poll now, that would be great. And in the meantime, as Kate mentioned, we'll have the second webinar in 2024, most likely in the spring of 2024. So stay tuned for the date and the link to register for that one. Fraser?
You should find the poll in the icon on the right.
Awesome. So if you look at the icon on the right, you should see a poll.
Under polls.
Yeah. Awesome. Thank you, Fraser.